LeetCode problem 199, binary tree, right side view. Given the root of a binary tree, imagine yourself standing on the right side of it, returning all the values of nodes you can see ordered from top to bottom. Okay. So we want to stand on the right, look at the right side, and then collect the nodes, the visible nodes from top to bottom. Okay, so first example, we have root 1, children 2 and 3, 2 has 1 child 5, 3 has 1 child 4. And the output is 1, 3, 4. Okay, so we're standing on the right side of the root, and then we're trying to see all the numbers. So this would be 1 and 1, 3. Oh. So this is technically the rightmost number, even though it's on the left side. So this is 1, 3, empty array. So I know for sure we need to take care of an empty array. If our root is empty, we return. Okay, so we need a way to store. So we are going to be using a queue for our tree nodes, starting with the root, and then what are we returning? We're returning an array of integers, so we'll need something to store that as well. Okay, so let's start with our variables. So first thing first, we can have one to store our answer. So we can just do for our answer, and that's going to be an array of integers. So we can do this and then make it, initialize it empty. And then we're going to use a queue to store our tree nodes. So we can do this tree node, and then we're going to start with our root. Okay, and then we want to account for an empty. If it's empty, we would just return. So we probably want to even do that first. So if we don't have a root, let's return a nil, or not nil, but an empty array. So that'll be our first. Okay, and then we'll probably need a while loop. So we know we're going to be returning our answer, because that's what we're going to be looping and appending to. Okay. So what do we do now? Okay, so with BFS, we are going to go by level. So we need to count how much is on each level. Okay. So when we start our queue is empty is false. What's it called? Let's just call it a branch. I don't think this is a branch. I think this is a branch, but let's just call it branch. Branch count will equal our queue size count. Okay. So now we want to loop through this for I in 0, 0, 0, our branch count. Just this. I had it right the first time. I'm so used to looping through a count. Okay, how did we do it with the DFS? We tried to remove our last, right? So we have our root in the queue. We want to keep looping through it while we still have things in our queue. Okay. So let's keep track of our current. And that would be our queue when we remove our last, right? And then we want to check if it's the last or if it's remove last. We want to check if it's the only queue, only node in the queue. And then if it is, what do we do? Okay, we can append it. We can do something like this. If I is equal to our branch count, if I is equal to our branch count minus 1, obviously. And then if that's the case, we probably can answer append our current. Current would be current val. Okay, current val, okay. Then now we need to get like our left and right. So we need to get our left and our right and populate our queue for our next round. So we can do we can do the same for right. If let right side equal our current right, then we can queue append right side. This should work. So we're adding the children to our queue for our next level. And then this is just checking if it's the last node. If I equals branch count minus 1. And then we want to append it to what we're keeping our answers. So we're looping through our current branch. And we take the first node from the branch. So this is how we get the branch count minus 1 is the right. And if it's the last, we can append the value to our answer, which is we need to return an array of integers. So this would work. And then we need to add the level that we are on, we need to add its children to our queue for our next one. Our next go around. Okay, so this one really helped. This would have messed me up, because I think I would have assumed that it would have been 1 and 3, because that's the right side. But then this doesn't have any children, so this would be the right side, the rightmost. Even though it's on the left side, it's the rightmost. Okay. Let's see what we get. Can't spell. Wrong answers only. So our output was 1425. We expected 134. How did you even get 4 before 2? Okay, let me relook at this. Okay, we have our guard, that's normal. Answer, Q. Okay. So while our queue is not empty, we get our queue size, and then we go through it. We remove our first. We remove our first queue. First in, first out. First in, first out. First in, first out. Wow, man. So that is great news. Okay, so all of these passed. This is our solution. This was pretty cool. Pretty cool question. Let us submit. Okay, 100%. That doesn't give me any kind of happiness. Let's go and look at some Swift. Straightforward breadth first traversal. Construct a map of row value while doing a breadth first traversal. Return an array of the last element of each row, as that is the furthest right, thus blocking the view of anyone standing to the right of the tree. So, okay, they're using a map. Okay, getting the max height. And then using the map. And then getting the left and right. Construct return with last value of each row. Okay. Kind of complicated. I'm sure it works. Okay. Beats 100% optimized. Get last element of BFT at every level. So level, okay, it's almost the same. They're very simple. Okay. Let's look at one more. Okay, they're popping first instead of removing. I mean, same thing. Okay. Q count. Okay, they're force unwrapping. Okay. So that is LeetCode problem 199, binary tree right side view.